Hi, boys and girls. Welcome back to Mr. Cedarbach's geometry class. Here's what we were working on today. So go ahead and open up your ebook to this lesson. Feel free to pause the video if you need some time to get there. And don't forget to take out your pencil and paper and write down today's lesson target. Feel free to pause the video if you need a second to get those out and to copy it down. What, you think it's weird to wear a bike helmet with a shirt and tie? Whatever. Let's get started.
Lesson 7.3.3. What kind of quadrilateral is it? Identifying quadrilaterals on a coordinate grid. Today you will use algebra tools to investigate the properties of a quadrilateral, and we'll use those properties to identify the type of quadrilateral it is. We're going to skip problem 138. It's a great problem, but we're going to save that in case your teacher wants to do that when you check in with them. We're going directly to 139, the shape factory. And instead of reading the directions here, we're going to patch you directly into the Shape Factory headquarters where you can meet and hear specifically from the president of the Quadrilaterals division.
Yes. I don't think so. Wait, what kind of trapezoid? Isosceles, right? You have to be specific. You know this. And what? How many? At this hour? Rhombuses. It's rhombi. Yeah. Oh, I gotta go. Hey, I was waiting for you. Congratulations. You've been promoted to the Quadrilaterals division of our prestigious Shape Factory. What an amazing honor. Now, don't be surprised that when you tell this news to your family, they don't quite get it. It's still a really big deal. Anyways, we brought you on because we have a problem. People aren't ordering the way they've always done. They used to just call in their order and say, hey, I would like a rhombus where each side is this long. Or can you give me a kite where the angles are this measure? No, not anymore. Nowadays, they're using these email machines and they're sending in these strange orders, and we need somebody brilliant like yourself to help us decode what they actually want. And so here's your job. With each order, we need you to graph the shape on graph paper. Step 2, we need you to identify exactly what kind of quadrilateral it is. And you need to be specific. Don't just say it's a trapezoid when in actuality it's an isosceles trapezoid. Don't just say it's a rectangle when it's a square too. Okay? And 3, we need you to prove how you know it's that kind of shape. All right? You need to just justify it. How can you tell by the fact that it's on a graph that the opposite sides are parallel or that those are right angles? Okay? You got this. We need you. We're counting on you. All right? Best of luck.
Great. So here are the 3 orders we need you to process. Now, if you forgot the instructions that he gave you, they're listed right up here above. There's the first step, second step, and third step for each. Give it your best. Now, when you graph it, you can do it on graph paper or you can use Desmos, which is what I'm going to use. All right, so hit pause, give it your best, and play when you've completed A, B, and C. Here we have the quadrilateral formed by the 4 lines given in problem A. What type of quadrilateral is this? It appears to be a rhombus. But how could we be sure? Well, we would have to prove the definition of a rhombus, which is a quadrilateral with 4 congruent sides. So are those 4 sides congruent? They look like they are, but we can't just base it on what it looks like. We have to prove it. So how can we prove those sides are congruent on a graph? Well, we can simply use the distance formula between the 2 points, or we can draw slope triangles and use the Pythagorean theorem. So if we do that, we can draw a triangle like this with a height of 3 and a width of 2. And by doing the Pythagorean theorem, we get 3 squared plus 2 squared equals this squared. And we'll just leave it in radical form, which would be radical 13. If you do the same thing for the 4 other sides, you're going to see that they have the same slope triangle. And so each of these is a hypotenuse of a right triangle with legs of 3 and 2. which thus proves our assumption it is a rhombus because it has 4 congruent sides. And we could say all equal radical 13. So we can go ahead and erase that question mark because we've proven it is in fact a rhombus. So here we have the graph of the 4 points from letter B. It appears to be a right trapezoid. But is it? How can we prove that? Well, you need to prove the definition of a right trapezoid. So find that definition. You can look at your shapes toolkit. Okay, so in order to prove this, we'd have to prove it's a trapezoid, which means it would have a pair of opposite parallel sides. And to be a right trapezoid, we'd have to prove that these are right angles. Okay, so let's try and do so. First, the opposite sides being parallel. How would we prove that those two sides are parallel? Look back at your work, how you prove lines on a graph are parallel, and try and do so. Hopefully you identified that you have to find the slope of those two lines. And so we can look here and you just pick 2 points that are directly on the line. And we make a slope triangle. And this slope triangle has a rise of 1 and a run of 2. So the slope equals 1/2. And then we can look at this one here and pick 2 points and say this also has a rise of 1 and a run of 2. So the slope also equals 1/2. So it is a trapezoid because opposite sides are parallel. Is it a right trapezoid? So now we need to try and prove that these are right angles. And so how do you prove that opposite side, I'm sorry, not opposite sides, how do you prove that lines are perpendicular on a graph? Take a moment if you need to search that or look back at previous work, hit pause and then play when you think you have it. Hopefully you found in order to prove lines are perpendicular, slopes have to be opposite reciprocal slopes. So this and these have to be opposite reciprocals. So let's look at the slope of this line. We go from here to here. We go down 2 and over 1. So that's -2 over 1. And so yes, those are right angles because -2 over 1 and 1/2 are opposite reciprocals. So it is a right trapezoid. Why? Because it has a pair of opposite parallel sides. Slopes are equal. And it has 2 consecutive right angles. Lines are perpendicular. Slopes are opposite reciprocals. So here we have the shape formed by the 4 points in letter C. It appears to be a kite. But is it? In order to be a kite, we would have to prove the definition of a kite, which is having two distinct pairs of consecutive congruent sides. Distinct meaning two separate pairs. If all four were congruent, it would be a rhombus. And so they have to have two different pairs of consecutive congruent sides. Well, it looks like they are, but how can we know? So let's try and prove that these sides first, here and here, are congruent. Now this horizontal one is easy. We can just count the squares and see that it's 3 units. This diagonal one, we would have to do either the distance formula or draw a right triangle and use the Pythagorean theorem. Let's do that. So this has a rise of 2 and a run of 2. And so by doing the Pythagorean theorem, we would get 2 squared plus 2 squared equals this squared. And that would be this squared equals 8, so this equals the square root of 8. And that tells us that this is not a kite because radical 8 does not equal 3. It equals approximately 2.83. So that tells us it is not a kite. It is just a quadrilateral. So we can't just go based on what it looks to be. We have to prove it using coordinate geometry. And in this case, our first assumption was wrong.